Hello. So let's talk about energy and different forms of energy. We're going to take notes. I'm going to take them on this paper here. You can find this paper just like it in our Files tab under Unit 7, Energy Transformations, Student Resources. So if you had a printer at home, you could totally print it off. If you don't, that's fine. You can take these same notes on any piece of paper. Just you can pause if I'm going too fast and you need a minute to write, totally fine, okay? But these notes are going to be really, really important and really handy for you during this unit, okay? So the first thing I want to talk about is energy. And what is energy? If you looked back in your vocabulary notes, you would know that energy is the ability to cause change. So all I'm doing here is turning my paper to the side, and here you're already familiar with potential and kinetic energy. We're going to put a word in front there. We're going to say mechanical potential and mechanical kinetic. Well, what does that mean? Well, up here, we're going to go ahead and write what that means. So mechanical is the sum, which means adding it up. The sum is just adding up the sum of the potential and kinetic energy of an object. Okay, so let's look at mechanical potential first. And the definition of this is the energy possessed by an object related to its position. So the energy possessed by an object related to its position. Now, well, that kind of makes sense because you remember what affects potential energy? Height affects potential energy. So right here, this car has a ton of potential because it's way up off the ground, right? It's height and mass that affects it. So the energy possessed by an object related to position. So some examples of this, just like we talked about, if you can think of a better one, you can write it down, but we could say a girl on a diving board, a skier at the top of a hill, my plant hanging off of my shelf over there. Any of these are good ones. I'm just going to write a girl on a diving board. She's getting ready to jump. So a girl on a diving board. So that'll be my example for that. Now, mechanical kinetic energy is the energy of an object related to its motion. I'm sorry, the energy an object has related to its motion. Okay, so you already know some examples of this. We're just looking for things in motion. One of them could be a bicycle going at top speed. This car being down here at the bottom of the hill, that's maximum kinetic energy right there. Rolling a ball or a baseball being thrown to another player. Anything like this, a race car going around, a track, any of these things, as long as it's in motion, would be a good example of mechanical kinetic energy. So I'm going to just write here, my example is going to be a bicycle at top speed. Okay, excellent. Let's go to the next page. Now we're getting into the types of energy that we haven't really talked about much unless you count our vocabulary, which I count it, it's important. And that is where we're going to get a lot of this information right here from. So let's see. So I got to scoot my things around. First, we've got radiant energy, and radiant energy is just kind of a fancy word for light energy. So I'm going to put Light right there. When you see radiant, think light energy, okay? The definition of radiant energy or light energy is energy in the form of waves that travel through space. Okay, energy in the form of waves that travel through space. Some good examples of this, boom, right here, we've got the sun. So we could put sun or a microwave, radio wave. Any of these things are radiant energy, even if they're not giving off light. Your microwave doesn't really give off light while it's cooking, but it cooks things radiantly. Kind of crazy, right? Okay. If you can think of any other examples, you can write it down. I'm going to stick with the sun. Next, we have chemical energy. And chemical energy, the definition is the energy stored in chemical bonds. So to remember this one, I always just see it like this one as being a cheater. So chemical energy, energy stored in chemical bonds, it kind of says it right there in the definition. So when you have to match these up on our assignments, chemical, chemical, boom. See what I'm saying? Some good examples of this are an apple. We've got a fire, gasoline. All of these things have energy stored in their chemical bonds. So they're great examples of chemical energy. So we can put food, gas. We could put a whole bunch of stuff down here. A battery. Batteries have chemical energy. Have you ever used those little hand warmer things? If it's cold outside, you get that little baggie and you kind of shake it up and it gets hot and you put it in your pocket and kind of hold it and it keeps your hands warm. Have y'all ever seen those? Well, those are a good example of chemical energy too. That's energy stored in the bonds. So any of these things you can write down for examples. They're really good examples, okay? Next, we have electrical energy. And electrical energy is the flow of electrical charge. This is another giveaway, guys. We've got electrical energy, electrical charge. I mean, there you go. There it is. So if you want to get down super duper small and talk about electricity, the stuff running through these wires that makes the sparks, that's electrons from atoms. Isn't that cool? That's the coolest thing ever. So if you see an electron moving somewhere in an example, that's electrical energy. Kind of makes sense. All sounds the same, right? Electrical energy, electrical charge, electron, all of these things go together, right? So we've got a picture here, some power lines. Those are really good examples of electrical energy. Your toaster, your refrigerator, your cell phone, your lights in the house, whenever you turn them on and off, anything you plug into the wall. Man, there's so many awesome examples of electrical energy running around. It's going to be hard to narrow it down. I think I'm just going to stick with the picture and say power lines. You can write down any example you can think of, though, for these notes. I mean, whatever you see sitting around you at home is what you can write down for your example. As long as it has to plug into a wall or have like a battery or whatever, that's electrical. Let's see what's next. So next on our list here is nuclear energy. And nuclear energy is energy locked in the nucleus of an atom. So energy examples of this, right here, we've got a nuclear power plant. That's a good example. Another awesome example that you might not think of is the sun. So our sun has nuclear energy because it's constantly doing nuclear fusion. That means the atoms are breaking apart constantly, and that's where all the energy that the sun has comes from. It gives off light, it does all kinds of cool stuff. Because of nuclear energy. There we go. Nuclear. And I'm going to write the sun here too, because that's a good example of nuclear energy. Next on our list, we have thermal energy. So thermal energy in our vocab is energy that comes from heat. So okay, energy that comes from heat. Anything that you have around you that gets hot are going to be some good examples of thermal energy. So they've got an iron in the picture. We could have your stove where you cook your food, a campfire. Sometimes, even when I plug my phone in, my charger gets really hot. Do y'all ever see that? Your charger gets hot if you just kind of put your hands on it and touch it? Man, that is thermal energy if it's getting warm. Okay. Our next type of energy that we're going to talk about is sound energy. Sound energy is energy that is made by vibrations and requires a medium like air, water, or soil in order to travel. So I'm going to say energy that is made by vibrations okay. All right, so sound energy, the energy that's made by bleh, the energy that is made by vibrations and requires a medium to travel. I bet you can think of some examples of this. Miss McCoy talking to you right now is a good example of sound energy. Drums, a guitar, clapping hands, a whistle, any kind of noise that you hear is good examples of sound energy. I'm going to write down drums because they make racket. That's a bunch of sound energy. All right. We got 3 more things we're going to talk about. The first one is energy transformation. Okay, so I got a different piece of paper, so I don't have to kind of write quite as much, but y'all can still see all the awesomeness, okay? So an energy transformation is the change from one form to another. I've got an example here. So this is a battery, and a battery has chemical energy, and a battery goes into a flashlight. What does that energy turn into in a flashlight? Do y'all know? The battery turns into electrical energy. And that electrical energy turns into radiant energy because when you turn the flashlight on, it gives off light, right? Okay, that's the energy transformation. Next, we're going to talk about a conductor and an insulator. So a conductor is a substance that allows the transfer of heat or electricity, electrical energy, okay? So a substance that allows the transfer of heat or electrical energy. An insulator is the opposite of that. So that is a substance that does not conduct heat or electrical energy. So that's just 2 opposites right there. We've already had these words, I think, a couple months back whenever we talked about metals, nonmetals, metalloids, conductor and insulator. Last but not least is the law of conservation of energy. And that simply says energy cannot be created or destroyed. It just changes forms. So energy cannot be created or destroyed. It just changes forms. So that's a super duper important thing for what we're talking about right now, because it's easy for someone to say that whenever you turn the light off, energy's just gone. Well, it's not gone. It just transfers into something else. Y'all are amazing. I hope you were able to take these notes. Remember, if you have any questions or you need to go back and rewind, that's totally fine. There's going to be some questions for you down below. I hope you have a wonderful day, and we'll see you tomorrow.